Okay, so hey everyone, welcome to the class. Today we'll be going over an interesting system design problem, and we'll share all the details like how to approach this problem. What are the important uh, things when we go over this problem. So this is some of the housekeeping stuff. Some of the stuff before we start. So you'll still see a form in the chat to submit your questions, doubt. We'll conduct a Q&A session later, and we'll send that invite. You can also submit your feedback. It will just take 1 minute time investment. We are doing all this hard work for you all so that you get successful in your interviews. Please always ask questions which are specific to this topic, not anything general like how can I prepare or what about coding, etc. And there will be a quiz that will be shared within 1 day after this class, and the winner will get $25, which is equivalent to roughly 2000 Indian rupees gift card. Okay, let's jump into the design problem that we'll be solving today. So let's say you work for a music streaming software company like Spotify, and you are asked to design a recommendation system that gets top end songs for each user as recommendations whenever they open their application. Recommendations will be based on the user song listening frequency over the last 7-day rolling period. For example, if a user opens their applications on 29th of January, which is 129, it will provide top end songs based upon the song listening frequency from 123 to 129, which means that while loading the recommendations, the data points around song listening from 123 to 129 will be considered. Similarly, if they open their application on 130, which is 30th of January, the recommendation will be based on the song listening frequency from 124 to 130. So as you can see, if we have moved by 1 day, we'll not consider the data which is beyond 7 days trailing window. Okay, and the difficulty level of this problem as per our analysis is medium. Okay, so first we'll talk about ambiguity resolution. First step as part of attempting the question is to solve the things around ambiguity as good clarifying questions, because the problem statement described is deliberately ambiguous. It doesn't provide all the requirements as such, right? So candidate is expected to ask questions like, what will be the granularity of rolling window? Will it be minutes, hours, or days, right? Minute based means, let us say, if a user opens their application on 129 at 1706 UTC, it will provide top end songs based upon song listening frequency from 122 170600 to 129 170600 UTC. R base means that it will be like round off to the R. Let us say if user opens their applications on 129 170600, it will provide top end songs based upon song listening frequency from 122 1700 to 129 1700 UTC. Day base means that let us say if user opens their applications on 129 170600, it will provide top end songs recommendation based upon song listening frequency from 123 to 129. And to keep the simple, keep the problem statement simple, considering the time, of the interview, let us assume that the granularity will always be in days, right? Which means that interviewer is your product manager or a customer who is giving you the requirements. And in this case, they want to follow the day-based granularity, which means the user opening the application on 129. It will provide top end songs recommendation based upon song listening frequency from 123 to 129. What is the value of n in top end songs? We'll start with n is equal to 25, like top 25 songs. However, n can change. So we should design the system considering this fact. How many users will be using this application? Let's assume there would be overall 10 million customers, and every day we have 1 million daily active customers. Is this a global product or a regional product? Let's assume it's a global product. Will it be a web-based application or a mobile-based application or both? Let's assume that it will be a mobile-based application supporting both Android and iOS platform, but our focus is on the backend design. Okay, some of the tips. Ask good clarifying questions, but keep a check on the time management because your interview is generally, I would say, 45 to 50 minutes when you talk about system design. Think of your interviewer as your product manager or a customer directly providing the requirements. And we have to work backwards. We should do the right design thinking about the customer requirements and pain points and should not over engineer the solution. Okay, with this, I will hand over to Pratul and he will be going over the system considerations.
Sure. Thank you, Sudhanshu. So now, as Sudhanshu has already covered the basic functional requirements, let's quickly go through what are the basic system considerations that we can take, and they are sometimes also termed as non-functional requirements. So the very first thing is we want our systems to be highly available, right? And one of the key metrics that might be just sitting out there is 99.99%, right? So what essentially it means is that basically your system should always be up and running. That is the basic definition of availability as we know. In some other ways, people can also measure it in terms of outage, right? So when we say we want our system to be 99.99% available, what we mean is if we standardize it over an year, you can do the math for 365 days, it means that our system should not be down by more than 52.6 minutes, right? So like that is some kind of budget that people always start with, that this is the agreement that we are doing with our customers. And if through the entire year, if we are having outages, sum of outages should not be greater than 52.6. Now, one of the critical demarcations here is there could be two kind of APIs or availabilities that we can be talking about. One is read availability and the other is write availability. Then we can also have a distinction that read availability is more important here. How? Let's say you are opening your this is streaming app. So the recommendation should happen right then and there, right? We cannot compromise on that kind of availability. Whereas can we take a little, discount on the right availability? Let's say we are listening to 15 songs a day, right? And one of these data points might not be captured into our systems. So is it still okay? So we are not saying that we are not designing a system that way, but it would be still okay. So one good way to say is maybe I want to have a read availability of 4 nines, and but maybe the write availability should be 3 nines, and that should be fine. Second point is performance. So in our case, as we are building a song recommendation system, so one key thing is we want our systems to have low latencies. So as again, another thing which is a standing out there is we want to have our P99 latency, which is measured as milliseconds. It should not be more than 500 milliseconds. What it means is that 99 requests out of my 100 requests should always give you the response in less than 500 milliseconds. So that is the SLA, service level agreement, that we are doing with our customers to provide a high performance service. Third key point is durability, right? We also want a system to be highly durable. To what extent we can always, have that discussion later on while we go deeper into the design. But durability essentially means that if I'm listening to 15 or 20 songs a day, every data point should be captured in the right way possible. And our objective is that these data points should not be lost, right? Even if your machine goes down or any other such cases, we should always want to have our system highly durable. Then security, as the name stands out, right? So we also need to have some kind of trade-offs there, that how we want to secure our data, right? One such security could be there could be some sensitive information in the way that this person is listening XYZ songs. So we want to have some kind of security mechanisms in place as well. So Siddhanshu, we can move forward. Yeah. Now we also want a system to be highly scalable and extensible. So one of the good keywords that I always come up with is just by throwing these jargons may not justify a design. So also understanding and justifying to the interviewer makes the most sense. So when we talk about scalability, so in very basic sense, what it means is the ability of your system to cope up with an increased load, right? Now load can be defined in terms of volume of traffic, right? Like the volume of data, the complexity of data, and the speed at which your data is changing. So whenever that is happening, you want your systems to be highly scalable, right? And one such example I'll quickly give, which I usually give to all the people, is now think of two systems. There is one system which is designed in such a way to handle a load of 100,000 requests per second, right? Each of size 1 KB. Now, this system looks very different from another system B, which is only catering a load of 3 requests per minute, each of size of 2 GBs, right? So what I've done is, like, if you can compute, the data throughput remains same, but these two systems are very different. So the kind of scalability that we do for our systems, it need to have strong assumptions. So these are the assumptions that we are taking, because if we are doing poor assumptions that whether our system is read intensive or write intensive, then whatever efforts that we will put in scaling our systems going forward, that will only result in like a lot of effort being wasted, and at the worst it could be counterproductive. So we want the systems to be highly scalable and extensible. Short description about extensibility is we want the systems to be backward compatible as well as forward compatible. Now what backward compatible in a nutshell, probably I can give a very basic definition is, uh, backward compatibility means, right, that your new code should be able to read your old data. And forward compatibility means if your old system is old, code is also residing in your system, it should be able to parse and read the new data. Quickly coming on to the cost. So cost comes in hand with the performance. So whenever you want to increase your performance, sometimes we have to shell out some more dollars, right? And we'll see later on how this cost can come into play, whether we are doing vertical scaling, horizontal scaling, how this cost can come into picture. So it should be always optimized, and we'll look into ways how we can optimize the cost. Fault tolerance and reliable. I'll quickly cover this point. So we never see a term as fault prevention. We always say, fault tolerant system. So it means fault tolerance simply, again, the basic definition goes like this is your system should be able to anticipate faults, right? And it should be able to cope with it whenever that happens. So what we are saying in a nutshell is we are not saying that we have to tolerate all kinds of faults. But any kind of faults, let's say network failures, one of your nodes going down, our system should be able to recover from that. So we want to design that kind of system. Eventual consistency, as the name suggests. So because it's not a banking problem, we don't need a strong kind of consistency that one amount is getting debited and it is getting credited into another account. So let's say if somebody is listening to a certain playlist, we can still put these right, all these requests into the right database. But if the person opens the app again in 5 minutes, we can still show the same recommendation. So that should be fine. Uh, so Danshu, we can move forward. Okay. So let's quickly do some, capacity estimation as I already mentioned. So here is some assumption. Again, these assumptions cannot be some very random numbers. You can always have assumptions like these. Let's say, Twitter or any other known well-known systems is already having some X million of users. And let's say we are designing a system which gets at least as popular as 10% of that, then I want to have that amount of users. So here we are taking an assumption that our system takes off and there would be 1 million active users per day. Sometimes it is also called as DAO, daily active users. And there is an assumption that we have already taken, right? So the assumption is a user typically opens this app 5 times a day and the user listens 15 songs per day. So just by looking at that, we can probably say that, our system is more write intensive. So it's a ratio of 15 is to 5, which is 3 is to 1, right? So now there are some assumptions that we have taken and we are going to compute the capacity estimation for traffic. So let's say there is 1 million, there is 1 million users and uh, there are 15 songs that this person is listening per day. So we do the computation, it turns out to be 175 songs per second, right? You can also do some kind of approximation instead of 86400, like 24 hours into 60 minutes into 60 seconds. This can also turn out to be 10 raised to the power 5. So I could also say that, 150 songs per second. One important point that is mentioned here is talking about the burst traffic. So what we are saying is we are spreading out these million active users across the day. But what if we can say that, all 1 million active users are really active at a timestamp T and they are opening songs or probably they are using the app. then I have a burst traffic of 1 million in that second itself. But typically that doesn't happen. But if you talk about these small little points to your interviewer, then your interviewer will have, better idea that, okay, this person is also thinking of interesting use cases. So similarly for the other one, song recommendations. So as we mentioned, it's just a ratio of 1:3, right? So obviously we'll get 60 recommendation requests per second. So Siddhansh, we can move forward. Okay. So now quickly doing a storage estimation. So what we are saying is, so this is where, some kind of cost also comes into picture. We want to store data, let's say for 5 years, right? So one kind of data retention policies, we might want to have this data, probably build some ML models on top of it and give recommendations to people. So there is again, another computation, 1 million users listening to 15 songs of half KB each. That turns out to be 7.5 GBs per day. You multiply it by 365 days a year into 5 years, we get around 14 terabytes. And then there could be a replication factor. So we may want to store this data into 3 different zones, availability zones, or typically called as data centers. So we need to have a storage of 52 terabytes, for 5 years, which is a decent or a reasonable trade-off that we can have with cost. So can we move forward, Sudhanshu? Okay. So I think this point we have already mentioned that, there are some assumptions because the system that we are designing, right, it can only scale well when we have set the assumptions right, that our system is write intensive than read intensive, right? Accordingly, we can scale our systems. So I think, yeah, we can go to the next slide, Sudhanshu. Okay. Yeah. So I think a candidate should always talk about some interesting use cases like burst traffic, as we have seen, right? Instead of spreading out all the active users throughout the day, we are also considering a case that is it possible that, all these 1 million users can come at a single time frame and start using the app, right? How our systems would be able to cope up with that. And then candidates should always discuss about the various things that, whether my system is IO intensive, whether it is reading, writing data into disk, or it requires a lot of memory to compute something, or it requires a lot of CPU to schedule a lot of tasks. So these are some of the things you should always talk with your, interviewer. Okay, high level design, I'll quickly cover this up because there will be a final design, which Sudhanshu will cover up. So here you can see a very basic structure divided into two different code flows or the paths. One is the write path and the second is the read path, right? So the write path is very simple. Whenever you are opening the app, which is the upper part of this diagram, whenever you are opening the app and listening to a song, we will flow this data, capture this song event that is happening through a write API, and ultimately this metadata is going to go and get stored into a certain storage. What kind of storage? We'll talk in the later slides. The lower part tells about the read flow or the recommendation API. So whenever you open the app, it will always go through the recommendation service and try to fetch the data for this particular user who is opening the app through the database where the data is stored. So now we can move forward. Uh, yeah. So I think this is something we have already covered. Yeah. Over to you, Siddhanshu, since you'll be covering the trade-offs.
Sure. Thank you, Pratul. So we'll be discovering, some of the good trade-offs, right? Making interesting design decisions, etc. And based upon the trade-offs, we'll be doing the final system design, which is we can say as low-level design or something which is more detailed oriented. Okay, so first is should the song listening data point recording be synchronous or asynchronous? So to provide good customer experience, the core functionality of this application is to enable the user to stream their songs, listen their songs, etc. Right? Processing the data point that user A listened to a song S at a timestamp T can be done in an asynchronous way. We want the core offering of the app to be decoupled from the data point recording in the backend system. Therefore, the processing of the data point recording will be done in an async way. So what kind of async mechanism we'll be using in the right path? So we can use a broker in the system design after the application servers get the request to process the data. Like user A listen to a song as at timestamp T, the application server can act as a producer. It will enqueue the request to a broker and return a response immediately after queuing the request in the broker system, right? Think of broker as a queue, right? You put it in the queue and the processors, who are polling the queue will basically take care of that. And the entity, which is producer producing to the queue, they can simply return. So this will allow the application servers to handle more requests, and application servers will have high throughput. We need a distributed, highly available, and high-performant broker to ensure the data is not lost and messages can be processed fast. We can either use Apache Kafka, AWS SQS, AWS Kinesis, or equivalent in Azure or GCP. We'll go with Apache Kafka as our choice because it has high throughput and can easily process millions of messages per minute and provides enough data retention period to ensure data is processed by consumer application before it is deleted from Kafka. So for our case, regularly like 6 hours is enough, but for safety, we can keep like 24 hours as a retention period. For example, in cases of some disaster or something really bad or terrible happens with our system, so that we have data retained in Kafka, which we can process. Additionally, Kafka provides a publish subscribe model, which we call as a pub/sub model, which means that the consumer doesn't have to poll the queue all the time to check for messages. Once the message is in queue, the consumer will get a callback to process that message. Unlike in SQS, so AWS Simple Queuing Service doesn't have by default a pub/sub mechanism. To have a pub/sub mechanism integrated, you have to integrate with a simple notification service in AWS. And if we already have something provided by Kafka, why to do extra work to maybe link SQS with SNS and have more operational load and do the custom work? So what kind of data partitioning scheme will be using in Apache Kafka? So the broker system uses an algorithm to distribute the messages to different partitions. All messages in single partition will be ordered. So one of the options we have is using the application server as a partitioning key. It will mean that all the data points from an application server will be ordered. And it might be possible that when a user opens the app and they listen to their first song, the request went to application server 1. And when the user listened to the second song, the request went to the application server 2. This might cause out of order issues in terms of messages for a particular user because two different servers are processing two different song requests. It will also mean lesser connections, which means that the number of connections from the application servers to broker will be dependent on the number of application servers we have in our system. We'll see shortly like how this is happening. How come the connections are lesser in this case? If you use user ID as a partitioning key, it will ensure that all the data points from a user will be in order. It will cause all application servers to connect to all the partitions of Kafka, which means more connections. So let's deep dive more into this. So if we use user ID as a partitioning key, think of like this user 1. When they listen to song 1, the request goes to application server 1. When they listen to song 2, it goes to application server 3. And when they listen to song 3, it goes to application server 2, right? So Kafka uses some algorithm to basically do the hashing. Typically, it's a very complex algorithm called Murmur. But for simplification, we have just put a simple hashing algorithm, right? Which is like key modulo number of partitions. Let's assume we have 3 partitions in Kafka, right? So if we go by user ID, regardless of where the request goes, right, all of them will be routed to partition 1 because 1 modulo 3 is 1. So you can see the purple line to partition 1, you can see green line to partition 1, and similarly blue line also to partition 1. Now, if the user 2 is listening, song 1, 2, 3, which are routed to different application servers, you can see that because the user ID is 2, 2 modulo 3 is 2, all of them are getting routed to partition 2, which means regardless of the server that is handling the request from the user, it will be based upon the user ID, which means that if you see in this case, application server 1, 2, 3, all of them are connecting to partition 1. And in this case of user 2, application server 1, 2, 3, all of them are connecting to partition 3. Now, if I have user 3 and user 3 is also, sending song 1 request to server 1, song 2 to server 2, and song 3 to server 3, all of them will go to partition 0 because 3 modulo 3 is 0. Right? This means that every application server is connecting to every partition of Kafka. Now, if we use application server ID as a partitioning key, regardless of who the user is. All the requests which are coming from application server 1 will always be routed to partition 1, right? All the requests which are served by application server 2 will be routed to partition 2 because 2 modulo 3 is 2. Here we are using key as the application server ID. Similarly, all the requests which are coming or handled by server 3 are getting routed to partition 0, which is 3 modulo 3 is 0, which means that any number of users, which these 3 application servers are serving, it really depends on application server. It doesn't depend on user ID. And this means that if you see the purple line, which is corresponding to application server 1, is only connecting to partition 1. It never connects to partition 0 or 2. Okay, so number of connections are reduced in this case. So given that each song will have a listen time and we should be able to persist the record in database correctly using that listening time, we don't care about ordering impact per user. To have lesser connections from producer to broker partition, we will prefer application server ID as our partitioning key. And this is good. If we scale out our system and if we use user ID as a partitioning key, there will be like so many connections and that can lead to connection thrashing, which is not good. Okay, should we use SQL or no SQL for this database? So SQL is ideal, not ideal when the data velocity is high, right? In this case, when we did some quant, we saw that the data incoming rate is around 175 requests per second in the right path. SQL provides good query support, is schema-oriented, provides transactional support, all the atomicity, consistency, integrity, durability guarantees. But these are not needed. We are not designing for transactions. These are not transactions. This is not a banking system, right? So we typically don't need all these cool things which SQL has to offer, like transactions, asset support, etc. NoSQL, on the other hand, relies on specific query access patterns to access the data when designing the database table and indexes, and is generally good to scale out. Right nowadays, if we talk about like AWS DynamoDB, it also supports transactions, but those transaction capabilities are limited. They don't match how SQL supports them. But we don't need transactions, as I said, we don't need asset things, etc. And our access patterns will be very concise, right? What we need in terms of our requirement, right? And given that we care about scalability, etc., and the data velocity is high, and as we get more popular, we'll get more incoming traffic. So it's good to have NoSQL system. So within the NoSQL umbrella, what kind of flavor we'll be using? Document DB like DynamoDB or Azure Cosmos DB, white column like HBase, Cassandra, graph DBs like Neo4j, etc. So this is not a graph problem, like for example, in LinkedIn connections or Facebook friends, etc. So we'll not be worried about using the graph DBs, right? Like Neo4j. We can use a document DB like AWS DynamoDB or a white column DB like Cassandra, which has a high availability SLA, provides several consistency models, strong eventual consistency, and has high throughput. So DynamoDB is one of the great DBs, right, in terms of it is always write available. And it is something which is a managed service provided by Amazon Web Services, right, which means that you just have to use the service and they will ensure that things are secure and it's highly available, and that reduces a lot of the operational churn we might have in our team or system. Okay, so will caching be required and what kind of cache if we go with caching? So caching will be of great help to provide the data to the client with low latency. As we discussed, one of the requirement with this question is that the P99 latency in terms of rendering the songs on user application should be less than 500 milliseconds. And this cache can store the pre-computed data. Thus, we'll not do the computations of top-end songs on the fly when we get the request. There could be like separate jobs that will run periodically, and the purpose of jobs will be to pull the top-end songs for each user and load it in the cache so that the data can be served faster. We'll not go with an in-memory cache because otherwise we have to do all the ops work to make sure the cache is synchronized, data is durable, and things like that. We can use either of the distributed cache like Memcache or Redis. AWS provides, both the flavors as part of AWS Elastic Cache service. We'll prefer Redis because it has some rich features like sorted sets. It supports pagination, which helps us, keep the data in cache sorted by the listening frequency per user. And using the pagination, it can be rendered in the correct order. Okay, very simple. What kind of load balancer? What kind of logic, within the load balancer? So we can use hardware load balancers. Generally, hardware load balancers are faster and they're not customizable. Software load balancers, on other hand, are more customizable because they are software based, but relatively they are slower than hardware. Given that we care about latency, we'll prefer the hardware load balancers, and we typically don't need any customization. We would prefer a least connection first algorithm when we have load balancers talk to application servers instead of round robin or random select, which means that a server having the least connections or serving the least request or less busy relatively to other application server will be given the request, right? And additionally, we'll use master-master configuration instead of master-slave configuration, which means all the load balancers will be active at the same time. Okay, some of the tips related to trade-offs. Candidates should discuss 6 to 7 interesting trade-offs with the interviewer. Remember, no design is perfect. It's all about trade-offs to fulfill the customer requirements and thinking about the future. This is your opportunity to show off the breadth of the knowledge you have. Candidates should be able to convince the interviewer about their design or technology choice by providing apt reasoning. The maturity of the solution will depend on the right trade-off decisions. Okay, now we'll talk of final system design. Pratul, you want to take over from here?
Yeah, I can take the next few slides. Sure. So can you move forward, Sudhanshu? Okay. Yeah. So I think this is more like the final design, after the discussion that we had. And now it is more refined from what we already started. So again, this design can be divided into two parts. The upper part is still the write path and the below one is the read path, right? So let's quickly see the write path first, which is on the upper top. So let's say you already opened an app and you started listening a song, right? The moment you start listening a song X, right, it will go through the load balancers and it will finally reach your song service. And preferably what it will do is it will publish this song metadata as an event onto the Kafka, right? Which is a message broker that, okay, this person is listening this song at a timestamp T. And probably it can later on also, calculate the total time this person has listened to this song for about 10 minutes, so on and so forth. So this goes into a PubSub model, which is Kafka that we are taking. And finally, it reaches to the DynamoDB, right? It has to go into a persistence layer. So that is how all these events are captured. On the other way, now this app can also be used in the same form that obviously whenever you are, which is the below part, right? So whenever the person is opening an app, so in the very first, as we have discussed, right, in less than 500 milliseconds, that is our P99 latency, a person should be given the recommendation that these are the top n songs, so let's say n equal to 20, these are the top 20 songs that you have listened very frequently and we want to show you through this. So again, the request will go through the load balancers and the song recommendation service will first try to fetch whatever the song recommendation I can give to this user using a cache, right? So that caching layer here is Redis, which is a persistent caching. And how this Redis is getting these data is there is on the extreme right, you can see, right, there are some periodic jobs. So there are some periodic jobs which are already fetching this data from the DynamoDB, which is considering this data from the right path and it is flooding it into the Redis DB, right? And let's say if there is a cache miss, right, like we are not able to find the recommendation for this user in this Redis, then obviously we have to go and fetch the data as a fallback into the DB. Definitely the latency will shoot, but not to the extent, that it should be. So yeah, this is a very simple and understandable design that Sudhanshu has talked about, and this is a complete layout. So now can we move forward, Sudhanshu? Okay. So I think this is pretty much the same which I've discussed. Over to data modeling. So I think Sudhanshu, you can take this up.
Sure. So data modeling is like very, very important. And this is where we'll address the rolling, stuff where we want to get the songs based upon the rolling 7 days. And this is the main algorithm of this problem. This is the meat of this problem, right? And this is like very, very important. So how will we modeling the data in DynamoDB to fulfill the rolling window requirement, right? So DynamoDB has a concept of tables, global and local secondary indexes, right? Table can have a partitioning key and optionally a sort key. And partitioning key plus optional sort key is the primary key, which means that every row has to be unique in the table in terms of partitioning key plus optional sort key. So we'll use user ID and /date as the partitioning key, which means a user A listening to song S1 at time T1. So AT1 is your partitioning key and your sort key is S1, which is a song which has been listened. And number of times the song has been listened on day T1, for example, and some metadata about the song like genre, artist, title, etc. So that we don't have to do extra joins, right? And in NoSQL, we don't have joins capability. So we'll store the data like metadata like genre, title, etc. in the same row. It's repetitive, but we'll do that like that. Similarly, AT1 listening to song S2 again 6 times, right? AT2 listening to song 3 times, right? Similarly, user B on day T1 listening song S3 9 times, right? So what do we do with this? So this is the table. We'll create an LSI, which is a local secondary index. So a few things about LSI is that LSI has the same primary key as the table, but a different sort key. And most interesting point is that LSI can have repeated records, means the records don't have to be unique if the records are distinct in the table. We'll see it shortly, like how this is possible. LSI does not need to project all the columns of the main table except the partitioning key and the sort key of the table. Keep in mind that LSI uses the memory units of the table, the read capacity units, write capacity units, and all the cost, etc. So it should be carefully constructed. If you over-engineer and create more LSIs and don't do the right data modeling, then it might be, you might be ending up spending more dollars. Table and LSI are designed based upon the specific query patterns. As I mentioned, like NoSQL, when we design, we have to really be careful about what are our access patterns, and we design like that. It's not like rich like how SQL offers. So LSI will use the same partitioning key as a main table, but a different sort key, which is the frequency in this case. So if I go 2 slides back, AT1 was listen to song S1. Like user A listened to song S1 on day T1 6 times. Similarly, user A listened to song S2 at day T1, same day 6 times, right? Now, if you see the records are unique, right? Because AT1 plus S1, AT1 plus S2, right? They're different records, right? But if you go to LSI, if the sort key is frequency and the frequency is same, right? You see the records are repeating AT16, AT16, which means that uniqueness is not something that is required to be handled in LSI as long as the records are unique in the main table. In the main table, our sort key was song ID. So partitioning key plus sort key, the records are unique. AT1S1, AT1S2. However, in LSI, AT16, AT16, they are not unique based upon the partitioning and sort key, right? So with LSI, what we will be able to do is that, for each user for the trailing 7 days, like we'll get like top maybe 8, 9 songs or 7 songs, right? Similarly, we'll do for day 1, day 2, day 3, up to so on and so forth till day 7. We'll get top and songs just from LSI. We'll not scan the whole table. And if you see the frequency is a sort key. So if we talk about like descending order, all the records will be sorted based upon the frequency. We'll just get the top 7 songs for each day, and the processing jobs in the final design, which Pratul presented, they will be doing the aggregation and loading the data in the cache. Okay, so I'll quickly go to AWS console and show you some practical. Okay. Okay, so this is our AWS console, and this is the table which I have created, which is user song records. It's an active table. It is provisioned for its read and write capacity. And If you go here, right, and see the indexes, right? So I'll go with the main table. You can see user ID / day is the partition key, and optional sort key is the song ID. And we have created a local secondary index, which is user ID day. Local secondary index means that partitioning key has to be same like the main table, but the sort key can change. The sort key here is frequency. And if we explore the table items, right, first I'll show you all the data which I have inserted in this table. I'll just select the table and I will do a scan operation and run it. So we have like several like AT1, for a user A on day T1, song S1 to song, S12 and different frequencies, right? Some of the frequencies of some songs are similar, 12, 12, 12, 6, 6 for S12, S4, etc. Now, if we go to, like the index, because index is the stuff that we'll be pretty much using for faster access, right? We'll go with a query. We'll not scan the whole table that can have millions of records, right? It will take a lot of time. So we'll do a query mode, which means that we are specific, records we are doing, from this index, which is frequency based, right? And I'll just select A/T1, right, for this user, and let's say I do like maybe greater than 9, right? So it will just give me very fast, these records. I can also do this descending wise. So if you see, the records are sorted by descending. So which means that if I were to use a scan operation, I have to I have to scan all the records in the table for each user. That will incur a lot of time. Instead of doing it faster, I will just create this LSI, which is frequency based, sorted by frequency. For each user, I will get top N songs, top 7, for example, or top 25 or top 30, right? Whatever the requirement is. And then for each user, I'll get it for last 7 days, like top N songs. And the aggregation will be performed by the jobs, which we presented in system design, like final system design, and they will be loaded in the Redis cache. So going back. So Redis. So in the Redis, we'll store like this. As I said, Redis provides some rich features like sorted sets, pagination, etc. So for example, for user A on day T6, if the user on T6, opens their app, they will see, their recommendations. What are those songs, right? And it will have all the metadata so that we don't have to get the data from other system, and we will load the data on the fly in a highly performant way. Okay, some tips. So data modeling is one of the most important aspect of the system design interview. Good data modeling is required for high performance and lower cost. Always consider to avoid hot partitioning problem through the right data modeling. We are deliberately not covering hot partitioning problem like how we are addressing, because it will be taught through quiz. Candidate should have strong basics. It's good to know basics of document database, wide column database, graph database, and cache. You don't have to know like 15 databases. If you know your basics very well for each of these database technologies, if you peel the onion, pretty much all the databases are using the same stuff. So interviewer is not looking for the specific domain knowledge like internals of MongoDB, for example, but your basics should be very strong in terms of database modeling. Okay, I'll hand it to Pratul to talk about some of the interesting use cases.
Sure. Thank you, Sudhanshu. Okay, so some of the interesting use cases that we can also, cover in the last 10, 15 minutes with the interviewers. So one such point is concurrency, right? So there is an interesting use case that we have talked about here. Let's say there is a single multi-user account and there is a user S, which is already listening to a song A from that particular account. And let's say this user also has a sibling and he has also logged in into some another device using the same account and again listening to some other song. So how do we handle this kind of concurrency? Because both of these requests will be fired, to get written into the DynamoDB. So there is a concept of optimistic locking, right? And they achieve it through versioning. Obviously, at this point of time, there would be it might take a lot of time to explain this, but in a nutshell, I'll try to explain it how it works is. So every update will happen with a certain versioning. So what happens is now with this use case, there would be two concurrent requests that they are trying to update the same record, right? Because the account belongs to the certain user only. But there are two people who are listening through this account for two different songs. So what will happen? There will be some kind of race condition between them, but one will always win, right? Probably resolved by certain milliseconds or microseconds, right? So what will happen? There are two background threads who have started racing around to update a certain record. So what they will do is will fetch the certain version and try to compare and contrast. So thread 1 and thread 2 will try to get the version. Let's say that version is v1 of the record. So whichever thread was able to reach first and read that, okay, I was trying to update the version v1, and right now database also has a version v1. So it will update it, and now it will change the version to v2, right? Now the second thread already has a version v1 of the record, and it will also try to fetch from the DB. But this time it sees that, there is a version 2 which is coming out from the DB. So there is some kind of mismatch. Then it fails. So then again, there would be another. Now it will try to fetch the other version. So now v2 and v2 will match, and it will update the record, successfully. So this is the way. So again, concurrency is handled in different ways in two different DBs. So this is something that we have talked about DynamoDB. So do remember about optimistic locking, and there is a versioning system, how they will try to break these ties. So now we can go forward, Sudhanshu. Okay, quickly talking about security. So security obviously comes in handy, and it is one of the very crucial salient features that we should often talk about whenever we are designing systems. So one such way is to authenticate these people, right? That whoever is trying to catch hold of this, or rather using this particular app, who would be getting hold of the recommendation. So there is very simple logic that we can build here is every user ID is unique. So that will always be passed in the URL, and the authentication server or the authentication system will always give you a certain token, right? So in the backend, what will happen is the API will always try to check your bearer token against a certain user ID, whether it is valid for a certain time frame or not. If those two things matches, then obviously that person is granted to use this particular app, and it means that this person has already logged into the system. This person already has an account, and will go to cater the recommendation. Otherwise, if this bearer token does not matches with the user ID, then there would be a 403 forbidden, you know uh, kind of error that is given to the particular person. Okay. Second part is we often hear about DDoS attacks, right? Distributed denial of service attacks. So it means there could be some kind of fake API request, or some blocklisted IPs are there, and people are trying to bombard or overwhelm your system. So that is a situation of brownout that we might have heard, right? These terms, that your system is getting browning out. So why this brownout happens? Sometimes a surge of traffic or the burst traffic that we have talked in the initial slides, that could happen, often rarely, until it is not a peak season. Some people might be bombarding your API with a lot of fake requests. So that kind of legitimacy comes in hand. And what we do as a part of security mechanism is we can throttle those requests. So every user ID or some IP address, we can either blocklist it if we already know that, this is doing some kind of malicious attacks. Or with every user ID, we can limit it to a certain point, which is called as rate limiting. Beyond that, we can start throttling it. And then again, like, there could be interesting use cases. You can say that, okay, uh, these are my premium customers, they are paying me more, so obviously I want to have a higher limit set for these customers as compared to the other non-premium customers, right? And then rate limiting can have XYZ things, like it can have different algorithms, token bucket, leaky bucket, sliding window, fixed window, which we are not discussing at this point of time. So we can move forward. Okay. Other quick security knobs that we can also talk about is, one kind of thing is SSL termination that always happens at the API gateway level. What it means is, let's say your entire system is sitting behind, right? Like there is a service, you have to use that service, the song recommendation. So everything is sitting behind an API gateway in the most, best way possible. So what happens is an HTTPS request can still come to the API gateway. This API gateway will do that API throttling, will do that authentication for you, whether you are the right bearer token that you have. And once it moves this, request inside your system, so that is called as SSL termination. That at the API gateway, I still need to have HTTPS, but as soon as I am floating my request within the system, I can just do HTTP, right? So if you have this kind of knowledge and discussion with your interviewer, they would be more interested in that. Then data could be encrypted in various forms, right? Like data can stay at rest which is on DB, how you want to encrypt it, encode and decode, or whenever the data is in transit, whenever you are transmitting these data over the network, do you want to compress it? Do you want to encode it? Marshal and marshalling, right? All these things. If there is enough interest with the interviewer and during the interview session, then you can talk about these points. Then you can also perform threat modeling, very periodic penetration testing, often called as pen testing. It has 5 stages, different like what are the vulnerability features, and you need to scan all of that. So these are the things you can talk about with your interviewers. So we can move forward. Okay, testing. So I will not spend a lot of time here because most people would probably know. So whenever we are trying to launch a feature or build this system, people should always do different kind of testing, unit testing, integration testing. Scale testing is often, as we discussed, right, it depends on the load, the volume of data that is coming in, the complexity of data, and the speed at which your data is changing, right? So how your system is going to scale out whenever you are like bursting your system with whether your system has a capability of scaling out automatically, right? Because we are going to use serverless architecture. So does it provide that kind of flexibility or not? You also want to do a functional testing. Functional testing simply means that obviously your system should be able to perform correctly even in cases of adversities. What kind of adversities? You might be having some kind of hardware, hardware faults, software faults, or even to the manual user that your user can trade in with different inputs, they can still get the right output. So that kind of functional testing and performance testing in terms of latencies. Okay, we can move forward. Yeah. So now these are a bunch of things. I'll just quickly talk about a few. Right. Security testing. So again, it's a domain of entire security. You can read more about it, but you should know a little bit about it, that how you want to, send out your request, as I mentioned, like SSL, TLS, and how that SSL terminations at the API gateway, how you want to prevent the DDoS attacks, what kind of penetration testing you might be interested in your system, right? Alpha beta testing, often called as probably A/B testing or gated rollouts, right? So whenever you are trying to roll out this API for your customers, you may want to target just 1% of your users through web lab dial-ups. Like you can, target using different marketplaces. You may want to launch this feature in one marketplace, let's say United Kingdom first. Then you want to go it to D, to Germany, to France, right? So these kind of dial-ups you can also do so that your system is always able to identify the errors beforehand and can probably, do a rollback in case of some kind of failures. UI UX testing, quite possible, right? Like localization testing. If your system app is looking something like this in India, how it will be looking in Russia, right? Because those languages would be different, right? So ease of use testing, and there should not be any crashes. We can move forward. Cost. Okay, as we have already discussed, right? Like performance and cost often go hand in hand, not necessarily in the same direction, but whenever we are trying to achieve a high performance system, sometimes we have to shell out, a few dollars more. Again, this is not directly tied, but still, but there could still be some efficient ways to reduce the cost and still get the right performance, right? And that's where those assumptions come in, as I mentioned, that how your system is going to scale totally depends on the kind of assumptions that you have taken. Assumptions in terms of what kind of operations are happening more commonly as something which is not happening rarely, right? Those assumptions will set the bar that how you are going to scale your system. Otherwise, whatever effort you will put in scaling your system will go wasted, or at the max, it will be counterproductive. So here we have mentioned some of the things, as we talked about, that we can still store this data into AWS DynamoDB to a certain extent. Let's say our TTL, time to live, or retention policy is 1 month, but we still want to keep some data somewhere in case of analytics, or try to run some, uh, ML models on top of it. So we can move that data from AWS DynamoDB to AWS Glacier. So AWS Glacier, obviously, if at all needed, people can read from it and it will cost less, right? So this is some kind of frugality you can, it's more like archiving your data into some DB, which is not getting touched more. And the cost that is required there would be pretty much less. Then again, as we have discussed, right, using some kind of managed services. So it means you don't have bare metal services. You are already using some kind of Azure or AWS architecture, where like maintainability and operational load is sort of, half of the things is maintained. The infrastructure maintenance is happening at the AWS level, right? While you can only do some kind of config changes, XYZ things. And that's where like availability, you don't have to care for the scaling out of these things, right? That is already taken care. in these infrastructure. And like people can often read about infrastructure as a service, right? IaaS, like you are giving an infrastructure to build infrastructure, or just a SaaS, right? Where you can just do some config changes and try to achieve that kind of different customization for your systems using serverless architecture, which I already mentioned, instead of using bare metal services that cost you more. And again, the quality or the commitment that with which you are building your design can also reduce the ops burden a lot, and that can reduce the cost in terms of dollar value and in terms of human effort that is needed. So we can move forward. How to handle, okay, some again interesting use cases. We are also reaching to the end of this session, so we are kind of on time. Initial loading, let's say this is my very first user which has come and there is no recommendation, right? So one such fallback could be that let's say I am from India, I'm logging in for the very first time. There will not be any recommendation metadata in the system. So my system can still fall back to some kind of recommendations based on my location. That okay, if I'm from India, probably I want to listen more of Bollywood songs. Right. How to handle pagination? So again, since we are using DynamoDB and Redis, so again, we should have that kind of knowledge that these two systems always provide support, like they always support pagination. So we don't have to do any kind of write extra business logic to cater this on the client side. Okay, some kind of additional things. I think this is something which we have talked around in between that probably we can also put a front end cache, right? So that's pretty common that let's say if a person has opened the app and I've got a recommendation for this person. Now this person goes back and again opens the app in the next 40 minutes or 1 or 2 hours. We can still cache the previous results, right? Because sometimes these operations are expensive, right? Getting those recommendations. So we can still cache it. And even after 1 or 2 hours, we can set a limit. The person can still be catered using that recommendation, which he got for the last 1 hour. So that is still okay. So that kind of additional things that we can talk about with the interviewer. Uh, yeah, and then we can build out different data models, test and train those models to see what kind of song recommendations we can provide to any kind of users, right? Listening on their histories, uh, maybe. Yeah, so these kind of ML models can always be approximated. Topics what we have not covered deliberately is given the, so obviously we have to be very cautious during our interview. Right now we have covered a lot of points within 1 hour. uh, and if there is enough interest with the interviewer, you can always discuss about other points. But in this particular session we haven't talked about extensibility. uh, we did not go into a lot of details of fault tolerance, monitoring, logging, deployments, and availability, right? But as I mentioned, if there is enough interest with the interviewer, if they want to double tap on a certain thing, you should be very, well versed into identifying these things. And also, you should be able to stand your design well, right? If I've built something, I should have the rationale why we are doing this versus that. Okay. So I think KPIs, Siddhanshu, you want to take over?
Sure. So when we are attempting the interviewer wants to see, we should just not think like a developer. We should think like a product guy, right? Launching the product, we are the heart of the product. So we need to provide them like business KPIs and technical KPIs, right? Business KPIs like how many clicks we are having on recommendations to make sure the recommendations we are loading or entering to them are good enough, are in their interest, and that will incur more daily active users, increasing app opening because users liking the applications, the performance is good, the UI is good, the experience overall is good. We'll get some qualitative customer feedbacks like how we are doing, and we should have a lower number of incidents reported by customers like app crashes or the latency is high, right, or the experience is bad, so on and so forth. Similarly, in technical KPIs, we can provide like latency in rendering the recommendations on the app, system resource utilizations like memory, CPU, heaps, threads, etc., system availability and uptime, and the data durability. So I would also like to cover, because time management is very important because it's a 45 minutes to 50 minutes interview generally, right? Talking about the core problem. Ambiguity resolution, we should cover in 5 minutes. Importance is high. System considerations, again, we should target to finish in 3 minutes. Again, importance is high. Capacity, quant, 3 minutes high. HLD and component responsibilities, 5 minutes. Again, importance is high. Trade-offs importance is very high, and we should definitely discuss very good and interesting 6 to 7 trade-offs, showing off our breadth of knowledge. And then final system design, we should discuss at least 5 minutes, I would say. Again, importance is very high. Data modeling is extremely high importance, again, 10 minutes. Then concurrency, 3 minutes, security, 3 minutes. Fault tolerance is very important to discuss. Our system handles the fault tolerance, but we have deliberately not covered as part of this exercise, which we'll cover in other exercise or through quizzes. Extensibility is very important as well. Again, cover it in 3 minutes. And then some of the interesting cases, if you have time, just talk about it in 2 minutes. Again, importance is medium. KPIs also is medium importance, 2 minute, right? Testing, again, 2 minutes, low importance. Again, cost also, if you have a time, just talk in 1 minute. Okay, some final tips. Ensure you have a good communication in the interviewer with the interview with the interviewer. Good collaboration is required. So after the ambiguity resolution, you're expected to lead and drive the interview, right? And your interviewer is just a spectator. And it's more like you're working in a same team designing something. So think about this session as a collaborative session, right? If the interviewer and interviewee were to work in the same team, will they like working with each other or not, right? What is the collaboration? What is your attitude, right? And do you have a team spirit or not, right? Which is together everyone achieves more, right? And always thank the interviewer in the end. It really goes a long way based upon my experience. So next steps, in the Teams chat, we have pinned a message where you have a feedback link, which is how's my drive. As a courtesy, please provide your feedback, which is just a 1 minute time investment. We are doing all this hard work for your success. We don't want you to buy expensive cohorts and waste your money. So please utilize these sessions and please provide feedback on how we can provide and improve customer experience, right? There's a link to attempt a quiz, right? You will be sent that link, right, within 24 hours, and the winner will get $25 gift card. And the person who gets the maximum answers correct will be the winner. And in case of ties, it will be based upon the submission time. The recording of this class will be uploaded on YouTube within 1 day. And for questions and answers, again, there is a form where you can submit your doubts, questions, queries, etc. We will collate everything and we'll conduct a doubt clearing session via live streaming shortly, and we'll keep you posted in terms of the invite. Okay, with this, I want to thank everyone for bearing us, attending this session. I hope everyone learned something cool this morning in Pacific time and this evening in Indian Standard Time or wherever you are in the world. So just wanted to, share some gratitude feeling. Cool. Thank you, everyone. I'm going to end this class, and this recording will be uploaded on YouTube shortly. Okay, thanks.